It's only in the last century that a fair measure of success was achieved by man in exploring the ocean floor and discovering the details of the topographic features. Considerable help was received by the invention and continuing refinement of sonic depth finding instruments, which are capable of making continuous recordings of the ocean depths by the use of reflected sound waves. As a result of unimaginable progress in the field of the science and technology, man has at his disposal such sophisticated devices as the Scripps Oceanographic Institute's deep sea drilling ship, the 𝗓𝗏 Challenger, and the deep diving vehicles like the 𝗧𝗏, which has reached down to a depth of 11 kilometers below the sea level. After this lesson, you will be able to understand the ocean bottom, hypsographic curve, and a few of the important features and their characteristics in detail. Until the most recent exploration of the oceans and the seas, people believed that a large part of the ocean bottom comprised of the flat plains. Presently, this cannot be accepted as it is far from the truth. As a matter of fact, the ocean floor is characterized by such irregularities in its land surface as are found on the continents. M.F. Maury, one of the founders of the oceanography, published the first bathymetric charts in 1854 that covered the Atlantic Ocean from 10 degrees south to 52 degrees north. Later on, concerted efforts were made to get information regarding the relief of the ocean bottom, not only for scientific reasons but also because of its practical applications. The most important event in this manner was the establishment of first transatlantic cable connection between Newfoundland and Ireland in 1858. However, prior to the laying of the cable, preliminary soundings had been taken to find the most convenient path for it. The first experimental, physical, chemical and biological investigations in the deep sea were undertaken in 1868 and 1869 to 1870 by the English ships, namely Lightning and Porcupine, in the North Atlantic Ocean. Later on, he organized a historic voyage of the Challenger into the Atlantic, the Pacific and the Indian Oceans. This was the most extensive oceanographic expedition ever made. At the same time, similar work was done by the German vessel 𝗪𝗟, though it was not as comprehensive as the Challenger expedition. In 1919, 𝗪𝗵 made more reliable echo soundings, solving many technical problems. The American vessel 𝗕𝗏𝗏 in 1922 undertook the task of taking first profile between United States and Gibraltar. Later on, in 1925 to 1927, the German vessel 𝗕meteor took the first systematic sounding in the South Atlantic Ocean. However, despite the vast amount of new soundings taken by the means of echo sounding, the knowledge of the bottom relief of all the oceans remained scanty. Later on, a new technique was developed which is known as wire sounding. It was superior to the echo sounding technique because it could provide samples of the ocean bottom. In the recent past, a large number of bathymetric and the nautical charts were published which increased the knowledge of the ocean bottom relief of the oceans. In 1935, Stokes and Wust published a bathymetric chart of the oceans. Besides, the International Hydrographic Bureau of Monaco also published similar chart for the world ocean on the scale of 1:10 million. All these charts show that there is a remarkable regularity in the bottom relief among a multitude of topographic forms. The hypsographic curve shows the distribution of the Earth's solid surface at elevations above and below the sea level. Areas are represented by lengths along a horizontal line, and heights and depths measured from the sea level are represented by vertical distances from this line. Thus, it is evident that 71% of the Earth's solid surface is to be found beneath the oceans. The mean elevation of the continents above the sea level is 840 meters, and the mean that the oceans is 3,865 meters. The curve shows the percentage of the Earth's total area, land area and ocean area at depths and elevations indicated along the margin. A glance at the hypsographic curve indicates the floor of the ocean is to be divided into 4 parts: continental shelf, continental slope, deep sea plains and the oceanic deeps. Continental shelf. The continental margins which is being flowed by the oceans are called the continental shelf. It is geologically part of the continent. This part of the sea floor has very gentle slope. The continental shelf may be defined as a shelf-like zone extending from the shore beneath the ocean surface to a point at which a marked increase in the slope occurs. It extends to a depth of 100 fathoms. Actually, on the seaward margin of the continental shelf, the depth of the sea is not uniform. According to 𝗪𝗏, the average depth of the water on the margin of the shelf is 72 fathoms, even though in certain areas it is as much as 250 fathoms. The width of the continental shelves varies in different areas. In certain areas, the shelf is practically non-existent, and in other areas, its width may exceed to 1300 kilometers. The broadest continental shelf is found in the North and the West Pacific Ocean from Alaska to Australia. Another area where the broadest shelf occurs is in the Arctic Ocean off the northern coast of Siberia and North America. However, the average width to the continental shelf is about 70 kilometers, and the average depth at which the continental break occurs is about 135 meters. As an exception, the continental break occurs at a depth of 350 meters around Antarctica. The continental break is the point where an increase in the rate of the flow occurs. The steepest slope beyond this break is called the continental slope. The average slope of the continental shelf varies from 0.2% to 1 degrees. But depending on the nature of the coastline and the variation in the form of the adjoining continent, the slope of the shelf may also vary. In those areas, for example, where the mountains of the plateaus flank the sea coast, the slope of the continental shelf is relatively steeper. As per calculations of 𝗂𝗚, the average slope of the continental shelves is about 2 fathoms per mile, even though the shelves have much steeper slopes towards the sea. But it is true that the slope on the shelf is never gradual, because in certain areas there are many submarine terraces, hillocks, and various types of depressions on the continental shelf. During a Pleistocene, the sea level was lowered as much water in the seas was deposited on the land as the glacial ice. The continental shelves in that period must have been exposed to the atmosphere and were grazed by animals. The teeth of these Pleistocene animals are occasionally dredged up by the fishermen. The width of the continental shelf is marked by great variations. Where the plains over the continents extend to the sea coast, shelf zone is usually very wide. On the contrary, in mountainous coastal regions, the width narrows down. Thus, it's clear that the width of the shelves is largely controlled by the topography of the coastal region. The average width of the continental shelf is 48 kilometers. But actually, the width may vary from about 0 to 1280 kilometers. For example, there is a great difference in the width of the shelves on the eastern and western coast of United States of America. In the coastal regions of the Atlantic Ocean and the Hudson Bay, the width of the shelf is up to 480 kilometers, while along the Pacific coast, because of the mountain chains reaching up to the coast, the width of the shelf is negligible. Near the coast of the Ireland, width of the shelf is 80 kilometers or even more than that. It may be stated that in the broader continental shelves, the slope is very gentle. On the west coast of Ireland, for example, the slope of the shelf is less than 1 degrees. However, the slope on the shelf is nowhere more than 2 or 3 degrees. In the Atlantic Ocean, the continental shelf occupies 13.3% of the total area. But in the Pacific and Indian Oceans, the percentage is 5.7 and 4.2 respectively. According to Wegener, the total area the continental shelves occupy is 30.6 kilometers square, whereas according to Kegel, the total area is only 29.4 kilometers square. The continental shelf is one of the most useful parts of the ocean to the man. The water on the continental shelf is shallow so that light penetrates to the sea floor. Because of the availability of the light of the nutrients, plants and animals grow and thrive in abundance in these regions. Naturally, therefore, the most abundant supplies of fish can be found in the continental shelf areas. Continental slope. The continental slope refers to a relatively steeply sloping surface lying seaward of the continental shelf. The continental slopes beyond the seaward margin of the continental shelf are features similar in the rate of the slope to the mountainous regions which are present on the continents. The break at the top of the slope varies from 1 to 10 kilometers above the deep ocean basin at its base. Even greater vertical relief is found in areas where the slope descends into submarine trenches. Usually, there is a gently sloping deposition surface at the base of the continental slope which is known as the continental rise. In fact, it is a deposit which is laid down at the base of the slope on the floor of the deep ocean basins. Average slope of the continental slope is about 4 degrees, but its steepness may vary from 1 degree to 25 degrees. The slopes of the Pacific Ocean average more than 5 degrees, while those in the Atlantic and Indian Oceans are about 3 degrees. It should be borne in mind that since the slopes around the margin of the Pacific Ocean are associated with the coastal mountainous regions in the submarine trenches, continental slopes are steeper relative to the other oceans of the world. According to Shepherd, the average slope of the continental slope is 4 degrees 17 minutes, but on the mountainous coast the slope is about 3 degrees 30 minutes. The most important point to remember is that the continental slope extends from a depth of 3,600 meters to 9,100 meters. On the basis of his observations of 500 profiles, Shepherd concludes that steepness of the slope depends on the nature of the coastlines. The continental slope associated with the volcanic cones by measure up to 50 degrees. Moreover, whenever the submarine canyons traverse the slope, their margins are almost vertical and highly dissected. A comparison may be made between the submarine canyons and the Grand Canyon of Arizona in the United States. The major characteristic of the continental slope is the fact that due to its steepness, the accumulation of silt on it is only nominal. Another important factor for the thinner deposits is the distance from the continental margins, due to which the supply of the eroded material is dwindled. Besides, that turbidity currents washed away the accumulated material on it. The availability of the light and the nutrients being deficit there is less abundance of the marine flora and fauna on it. As we are aware, without adequate light, plants are unable to carry on photosynthesis and animals that feed on plants cannot survive. Continental slopes cover 8.5% of the total area of all the oceans. However, the actual percentage in the different oceans is dissimilar. The most important characteristic of the relief of the continental slope is the presence of very deep canyons and trenches, origin of which is controversial. Like the steep escarpment, there is a lot of structural control on the relief of the continental slope. Continental slopes on the Atlantic coast of North America are actually the margins of the ancient rigid mass of Appalachia. Shepherd says a great deal on the ancestors on the diastrophic origin of such slopes, even though he accepts that the possibilities of the origin of continental slopes is possible by different processes. Submarine canyons. The submarine canyons are usually the steep-sided erosional gorges cut into the sediment and the rocks of the shelf and the continental slope. There, in fact, the most striking feature of the negative or depressed features of the shelf and the continental slope. They are similar to the canyons cut by the rivers in the arid or semi-arid regions. Some of the submarine canyons are as large or even larger than the Grand Canyon of Colorado. The submarine canyons are very often found opposite the mouths of the major rivers such as Congo or Hudson. Because of their distribution, it is believed that the rivers are mainly responsible for the formation of these submarine canyons. However, there are such canyons that are not located opposite the river mouth, either present day or ancient. The submarine canyons, like the canyons formed by the river erosion, have tributaries and steep V-shaped walls that exposed various types of rocks of different geological ages. The rocks exposed on the walls of the submarine canyons comprised of many types ranging from soft shales to quartzite and granite. One of the characteristic features of these canyons is that they are zigzag. Later on, in 1903, another scientist, Spencer, discovered several such canyons. His discovery revealed that the Hudson Canyon extended up to a distance of 224 kilometers from the continental slope. The submarine canyons are characterized by a lot of variation in the shape, size and other characteristic features. For example, the canyons opposite the mouth of the rivers like the Hudson and Congo extend from over the continental slopes to the mouth of these rivers. On the contrary, there are canyons which are found only on the continental slopes. As stated earlier, only some submarine canyons are zigzag, while others form a dendritic pattern with their tributary canyons. As regards the size, the submarine canyons range from small gorges to a giant sized canyon of the dimensions of the Grand Canyon cut by the Colorado River. There are yet other canyons which extend on the deep sea plain up to a depth of several thousands of meters. It may be stated that the submarine canyons are usually found near the continental coast, but sometimes are also found along the coast of the islands situated in the oceans. The walls of these canyons is being very steep or almost vertical. There is complete absence of the unconsolidated sediments on them. The walls comprise of sedimentary rocks, but there are certain exceptions too. Monterey Canyon along the coast of California was carved out of the granite rocks. The sediments deposited on the floor of these canyons consist of coarser materials and those on the continental shelves. The sediments may be as large as gravels and even pebbles. Of all the submarine canyons found on the Indian coast, those on the eastern coast deserve special mention. The following are the important submarine canyons found on this coast. The submarine canyon opposite to the Ganga mouth, Pondicherry Canyon, Pola Canyon, Godavari Canyon, Madras Canyon and Puri Canyon. From the structural point of view, there are variations in the longitudinal slopes of the submarine canyons. Though the average slope of these canyons is 1.7%, those associated with certain islands are characterized by having a slope of 13.8%. Usually, the depth of the bottoms of these canyons is 334 to 500 fathoms, but in certain areas the depth exceeds 830 fathoms. Shepherd has given the description of a submarine canyon off the coast of New England whose depth varies from 1166 to 1400 fathoms. A large number of submarine canyons have been recently discovered in the continental shelves and the continental slope of the Pacific in the Atlantic Oceans. Off the coast of New England, at least 30 canyons have been discovered. Similarly, many canyons are known to exist in the Gulf of Mexico and between Cape Cod and Cape Hatteras. On the west coast of the North America, there are 40 submarine canyons discovered between South Mexico and Vancouver Island. Similar canyons are known to exist along the eastern, western and southern coast of the continent of Africa, Portugal, France and British Islands, have also few submarine canyons on the continental shelves and the continental slopes. The deep sea plains. The deep sea plains, also called the abyssal plains, are a broad and nearly level area covering about 2/3 of the entire ocean floor. They extend from the base of the deep sea fans and marginal trenches. These plains lie at depths between 2000 and 3000 fathoms. They include flat surfaces with slopes of less than 1:1000. However, the deep sea plains are not as flat as were formerly thought. The 𝗪𝗵 expedition found from the continuous echo sounding that the bottom profiler radar rugged in detail. It is also discovered that despite the absence of steep slopes, the ocean floor is characterized by different types of topographical features. The major characteristic of the abyssal plains is the complete absence of sediments brought by the rivers. It certainly does not mean that the bottom is composed of naked rocks. On the contrary, that surface is covered with various pelagic oozes. In certain areas, volcanic peaks rise steeply from these plains and sometimes reach the surface in the isolated islands. In deeper parts are found the deposit of red clay, which appear to be the volcanic ash deposited there by the winds blowing over the oceans. Another characteristic feature of these plains is that those erosional processes which produce various types of landforms on the continent are not present there. In fact, the volcanic and tectonic activities reduce the bottom relief of these plains. Moreover, the effect of weathering and subaerial erosion being nil on the deep ocean floor, all the topographical features are characterized by extreme sharpness. Landforms produced by the submarine volcanic activities by folding and faulting conserve in their original form. Various research vessels with the latest observational techniques have successfully discovered various types of topographical features on the deep sea plains. The submarine features include the oceanic ridges, trenches, sea mounds, guyots, etc. The oceanic deeps. A large number of service ships have been tried to locate and sound the deeps in the oceans. The soundings made by the Challenger expedition were taken by using a fine hemp line with a weight tied on the end. This was of course very crude and old method, so that the accurate measurement of the depths was not possible. But with the passage of time, a very speedy and highly accurate method was evolved. Today, echo sounding is employed to measure the depths of the oceanic deeps. By echo sounding, either sonic or ultrasonic vibrations are transported down through the water to the bottom of the ocean, which returns in the form of an echo which is electrically recorded. When the accuracy of the highest degree is required, the ship from which measurement is to be taken is anchored. But for common purposes, a continuous profile is procured from the moving ship. The term oceanic deep refers to two types of depressions found on the ocean floor. The depressions are classified as trenches and troughs. Trenches are defined as long, narrow and deep depressions on the ocean floor with relatively steep sides. They are usually arc-shaped. Oceanic troughs, on the other hand, are long and relatively broader than the trenches. However, the sides have gentle slopes. The oceanic trenches in fact represent the deepest parts of the oceans. Most of the trenches are generally found near the margins of the oceans or along the outer side of the island arcs. Most of these trenches are usually found adjacent to the areas that have a great deal of volcanic and earthquake activity. They are most common on the convex side of the island arcs. There are many trenches, even the deepest ones found around the margin of the Pacific Ocean. There is one such trench close to the West Indies. Such features are characteristics of the rim of the Pacific or the ocean along the coast of South America, Middle America and the western margin in the Pacific Ocean. Trenches are also found along the coast of Aleutian Islands. It is worthwhile to bear in mind that the Challenger Deep and the South Pacific Marianas Trench is the deepest part of the ocean. In 1960, 𝗳𝗏 Donald Walsh descended to the bottom of that trench, which is 10,900 meters below the sea level. It is interesting to note that if Mount Everest, the highest mountain on the earth, is placed in this trench, it would completely be drowned and would still have 1.6 kilometers of water above its peak. Like the mid-oceanic ridges, the trenches appear to play a very dominant role in the geological evolution of the earth. It is the firm belief of a large number of scientists that the part of the earth's crust that is generated at the oceanic ridges is being recycled to the earth's interior by the way of trenches. This belief is based on the theory of the plate tectonics. Even though the opinions of scientists differ as regards the origin of the oceanic trenches, it seems just possible that the compressing of upper crust and the sharing of the crustal blocks must have simultaneously acted and contributed to the formation of the deep sea trenches. The major characteristic of these oceanic trenches is that they are generally asymmetrical. The slope near the land is much steeper than the one on the side of the open ocean. They are most commonly found near and parallel to the coast, closely flanked by young folded mountains. Of all the oceanic crust formed on the bottom of the ocean, Bartlett Trough in the Caribbean Sea and the Weaver Trough in the Molucca Sea are the most important. Though various hypotheses have been proposed to explain the formation of the oceanic trenches, more recent work has thrown doubt on the validity of the earlier interpretation of the submarine topographical features. The ocean floor holds the key to the evolution of the Earth's crust. Yet, until about 1960, there was insufficient information about the ocean crust. Earlier, it was believed that the ocean floor was simply a submerged version of the continents, and the ocean floor was quite uniform in relief, being made of sediments derived from the continents. Later developments in the science and the advent of new scientific instruments heralded a revolution in the knowledge of the ocean floor. It came to be known that the ocean floor is composed of materials quite different from the continents, and that topographically it was as diverse as the continents. And today in this lesson, we've learned about the morphology of the ocean bottom.